doing this here is because within the function topic, you're going to see a lot of set notation. So this should be a recap, and you should be thinking, oh yes, 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 I remember all this, she says optimistically. So the funny E means as a member or element of a set, okay? This funny C means subset, okay? So the 3 and 4 are a subset of 1, 2, 3, 4. These bracket things here, you probably haven't seen these before, but just to be aware that some textbooks may use this notation, and it is accepted as official notation. So you probably will have definitely seen things like that. Okay, this is telling us that the value of x is between 0 and 10 and includes them because of the or equal sign. Yeah, so we're talking about numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is another way of writing that. So the square brackets around it means that we are including those values, and it goes from 0 to 10. This one here, you'll note, goes from 0 to 10, includes 10, but doesn't include 0. And so when we're using the bracket version, it would be a curly left-hand bracket to show it's not including it. All right? So just so you know that that's what that means. All right? Sets of numbers. Now, you may or may not be very familiar with these. You should recognize them. And N, these natural numbers, so counting numbers. Okay, so they are whole numbers, but notice they are not negatives. All right, and it also does not include 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, they are the natural numbers. Whole numbers. Whole numbers does include 0. Okay. Z stands for integer. What's an integer? Tell me more. A whole number. Okay. So integers are whole numbers. Okay, they can be both positive or negative, and it does include 0. Q is a rational number. Rational number means that it can be written as a fraction. So you may look at 0.3 recurring and think, well, that's not rational, I can't write that as a fraction, but you can, that would be 1/3. Okay? Most numbers, okay, most are rational. So if you're looking at something thinking, not sure, go with the rational option more than the irrational, okay? Irrational numbers are those special types. So things like pi, okay? You can never write that as a fraction. It's approximated to 22/7, but it's not exact. Root 2 is another one, okay? Cube root of 7, there's lots of them. So if you have something that looks a bit fancy pants, then that one probably is irrational. Does that make sense? So if you're looking at a general set of numbers, most would be rational. If they've got something that looks a bit weird, it's probably irrational. And they're the ones we need to focus on. So rational is Q, irrational Q dash. R is a real number, pretty much the whole gamut. Okay, so numbers, when we talk about real numbers, we talk about everything we're interested in. R plus would be positive real numbers, for example. Okay, so if they've got some kind of sign next to it, it's just limiting it to positives and negatives. All right? Yeah, good. So that should have been familiar, yes? All right, so a relation. Now, I've been a bit sneaky here, and I kind of just snipped this all from the text. I should write here somewhere Oxford text. Okay, so the whole pages and malarkey from the Oxford textbook. This one should be able to wish to find it. Just one of those books. Okay, relation. It's a set of ordered pairs. There's nothing special about the numbers in relation, so it's just coordinates essentially. Alright. Domain. If we talk about the domain, this should be familiar to you. The domain of things are your x values. You would have done this at GCSE. It's one of those things that often goes in one ear out the other. But the domain are the x values. Okay, so the input numbers. Okay? It does say x values, you may want to just clarify input. So it's what goes into your formula. The range are your y values or your output values. Okay? In other words, your answers. Find the domain and range of these relations. So A, domain. Which values are we sticking into our function? And how can we tell that we're sticking it into it? One is one of them, correct? 2, 3, 4. Yes? How did you get those to me? They are the x values, yes?
Yeah.
There. Alright, the range then, Gisela, make sure you know what's going on. What's the range for that same thing?
4, 7, 3, 10, 30.
Okay.
3, 4, 7, 10, 30.
Yeah. Okay, pretty easy. It's unlikely this is going to come up, but you never know. B, domain.
-2, -1, 0, 1.
And range.
4, 1, 0, 1.
Now, this is where you need to stop. 4, 1, and 0. Why did I not write 1, 4?
Because it's the same thing.
Okay, you don't repeat things in these. Alright, so you would only list them once. So your domain is all of those numbers, your range is just 4, 1, 0. Okay, I'll just pause that. Right, where did I stop? What is it? So a function is a relation such that each element of the domain is associated with exactly one element of the range. So in order for a relation to be a function, no two ordered pairs may have the same first element. Okay? So you can have the same second value, so you can have the same y value. For example, we know that if we were talking about x squared, I know this is a function. I'm going to tell you that is a function. If I had 1, if I had 2, I would have the value 4, yes? If I had -2, I would have the value 4, okay? That's allowed. So I can have the same y value, I cannot have the same x value. Does that make sense? Alright, so which of these sets of ordered pairs are functions? So, are these all different?
Yeah. 3, 1, 9.
Okay, well, here we go, we've got an issue here.
I'm looking for this.
So is that a function? Is that a function?
No.
No. Okay, we've identified with the green. B. Is B a function?
Yes.
Is C a function?
Yes. Yeah.
Alright, good. Even though we've got repeated ones, that's okay. It's still a function. Alright, this is one way that you can, if you're given a diagram, you can check whether it is a function or not. Super simply. It's called the vertical line test. Now, good thing to do is to either have a pen or a ruler or something. Okay, you hold it vertically. What you do is you would run that pen or pencil or ruler across the function, across the diagram in a vertical manner. And if your ruler or pen or pencil only ever touches that graph one place at each time, that's awkward.
Oh, so C.
Yes, hang on.
Oh.
So, here, I've only touched it once. So, yes, this is a function. Okay? If you want to draw a few vertical lines, just to be clear. Exceptionally clear. Alright, this one is modulus x, so we're just thinking in the positive values. And again, lovely jubbly, yes, that is a function. Oh, here we go, here's the problem. As soon as you do that, you are hitting your line in two positions, so no. And that only has to have happen once. Like it doesn't have to happen consistently, but if it happens at least once, then it means it wouldn't be a function. Does that make sense? And that obviously this is only useful if you've got a picture of it. You don't always. What's all this business?
Domain and
So you can optimize domain and range using interval notation. All right, so this is going back to this malarkey here. Let's have a look. Where did I get up to? Those united.
no, it wasn't my same page.
Yeah, I know. I don't know why I put that in there. That's talking about stuff like this. So no, don't scratch it out. A little bit of a repeat. So you can show that it's an interval, like the inequalities. If you're saying that x is less than 3, you could also say that that means that you're going all the way to negative infinity and then up to 3. Yes, remember that bracket version I was telling you about? So that would be that version here. If it had said x less than or equal to 3, then we would have, and we'd have a square bracket on that side. Yes? Lesbians? Alright, so function notation, this should be familiar. So this is f of x, how we say it. This rule here is 2x plus 1. Okay, you may see it with these colons and arrows. Remember that from GCSE?
No.
Alright, it just means exactly the same. So just don't get freaked out if you see colon with an X and an arrow. It means exactly the same thing. Okay? Oh, shush. All this is hopefully should just make sense. X, Y would be X, Fx. So this represents the Y value that we're commonly referring to. Alright, okay, so finding fx for a particular value means evaluating the function at that thing. So A, it says evaluate the function fx equals blah blah at x equals 3. So what are you going to do? So you're going to substitute x equals 3 into function. And we write that fancy pants way as writing f bracket 3. That's what that means. So if you're substituting the value of f of x is 3 into the function, it means you're finding f3. So 2 bracket 3 plus 1. So that's 2 multiplied by 3 plus 1 gives 7. That's full of more sense. I like to always think that I hadn't, so B, just rule for B, okay, so be aware, just rule for B, but, so in here, they've got an X currently. Here, they've got a 2. So that tells me that whatever letter I had here originally, I'm now just going to put that number instead. So that's a good way of thinking about it. So wherever you would have seen this letter, you're now going to write this number. So f of 2 is going to be 2 squared plus 4 lots of 2 minus 3. Oh, that's not okay, we've changed it. Oh, look at the numbers. Alright, 2 squared is 4 plus 4 lots of 2 is 8 minus 3 is not Tresbians. Great. So we're now going to find f0. Oh, what is it? So f0, I'm not going to use colours because that took me way too long. So 0 squared plus 4 lots of 0 minus 3 is minus 3 Tresbians. F of negative 3. What do I need to be careful with here?
That I make a negative 3.
Yes, but what in particular for this function is more stressy, the fact that it's negative 3? When you square it, good.
Because minus 3 is minus 3 is just not.
Good, so you need to be using brackets, or make sure you're at least thinking brackets. If it's on the count paper, which this is unlikely to be honest, But if you put just negative 3 squared into a calculator, it will tell you it's negative 9. Okay, unless you put it in brackets. And so that's plus 4 lots of negative 3, 2 3. So that's 9 minus 12 minus 3. That's negative 6. Yeah? And then this last one, it says x plus 1. Okay, so what are we going to do now? Do you remember? What was that? What did we do for all these others? Just whatever was in the bracket, we substitute in place of x. Whatever was in the bracket, we do the same thing. Say whatever is in the bracket, we substitute for our x. So our x plus 1 is going to be x plus 1 squared plus 4 lots of x plus 1 subtract 3. Now, you wouldn't leave it like that because this can be simplified. So I would use FOIL to expand. I would probably recommend that you wrote your two brackets out so you don't make a mistake. I'll expand this bracket. And then you can join like terms. So we've got 1x squared, we've got an x, and a 4x. So I've got 6x, I've got a 1 plus 4, take away a 3, gives me that as my final answer.